three properties of logarithms. These three properties are going to allow us to expand or condense logarithms. They're going to allow us to simplify logarithms easier. It's going to be able to get us a real nice setup. This came up last hour about why are we looking at this and what is this going to help us get to? This is another one of those precursor lessons that's getting us towards an end goal of solving logarithmic equations. These are some tricks of the trades that you're going to be able to do. Now, what happens now is that we have three basic properties. The three basic properties of logs go like this. We have the product property. I would write these down. These are extremely important. We have a product property, a quotient property, and a power property. They look very, very, very weird, but as I go through these examples, I will show you what it means in terms of something simplistic. You will see right away that it is actually quite easy to work with. Hi. How are you? Good. I'm glad. So, product property. What does product mean? Multiplying. And if you remember, isn't multiplying the same thing as repeated addition? That's kind of why they go hand in hand. Let me show you a real easy example of what the product property looks like. If I say something like the log base 2 of 3x, that's 3 times x, do you agree? What this allows me to be able to do is break it apart. Log base 2 of 3 plus log base 2 of x. Again, the reason that we're going to be able to do this is because we're going to be able to use these types of properties to not only be able to simplify some of our statements, but it's really going to help us to solve equations more so tomorrow. It's just kind of like leading up to it. Okay? Notice all I did was split them apart, threw an addition symbol between them. That's it. When I use the division property, what's that? I can't hear you.
Can you prove that?
Can I prove that?
Yeah.
Not right now.
That was so well timed.
Why is there a
Because Pythagoras said so. I'll show you a real easy example numerically. You'll see it numerically. It works very cleanly. Okay. I'm just going to go through the generics first, and then I'll show you a numerical one, and you'll pick up on it real quick. I guarantee that. The quotient property. Quotient means what? Division. What does this bar kind of look like if it was by itself? Yeah, exactly. So that's how you keep that straight. So again, if I have the log, let's say base 4 of x over 6, and try to make it really easy, I just split that apart as the log base 4 of x minus the log base 4 of 6. Notice, all I really did was take that division bar and I slid it over to turn it into a subtraction bar. Okay. It's kind of a cheesy way to remember it, but that's one easy way to go through this. And then the last one we're going to work with is called the power property. The power property is, well, it works with exponents again. So if I say I have the log base 3 of x to the 4th, all that tells me is that it's 4 log base 3 of x. It really is kind of simple. Okay. It really is kind of simple. Now the reason why this works, if I let me show you one with the multiplication property. I'll show you one like that. If I show you the product property with numbers, you'll catch up on it real quick. Let's say I have the log base 2 of 4 times 8. I say I have log base 2 of 4 times 8. That splits it apart to log base 2 of 4 and log base 2 of 8. You guys agree? When you were working with simplifying these over the past couple of days, and I say, when we tried to simplify these things numerically, I tried to write that 4 in terms of a base 2. How can I rewrite the 4 in terms of a base 2? 2 squared. Okay. So I get log base 2 of 2 squared. And then this would be log base 2 of what? 2 cubed. So in this instance here, what happens to simplifying the log on the left? It just becomes a 2, and what's this one? And what's 2 plus 3? Okay. Now, if you go through the order of operations, and you went the other direction, what's 4 times 8? 32. That's saying the same thing as the log base 2 of 32. Can you rewrite 2, or excuse me, can you write 32 in terms of 2 as a base? It's 2 to the 5th. So you still get 5 when you simplify it out. Now, Gunn, the reason why we use these properties is sometimes this could have been 4 and an x, and that allow me to write it out differently. Okay, it's going to allow us to use logarithms and exponential values to solve equations. That's basically what we're getting towards. But does that make a little bit more clearer sense of why it works? I'm not going to go into the long-winded proof of it, because then again, I don't remember it. But I'm sure there is some astronomically long proof you could probably Google. How's that? No. Does that make sense, guys? Let's try a couple of these on your own then. Let's try try these first two. You blow it up a little bit. Try these two. I want you to simplify them. Use these power rules. Use these properties of the logs to simplify those out. Let's see what you get. You guys get that? Did you get that?
Yeah, I gotta take that out.
David, you got it wrong.
David. That's all look at him and shame.
Can't get anything right.
Again, the reason why this becomes a 2 is that's the same thing as log base 3 of 3 squared, and it drops and comes over. This one becomes a 1 because this is log base 3 of, as an exponent of 1, so it drops. Plus, it's also the property here, log base b of b is always 1. Yes, sir?
But like you said, we could just do log base 3 up to 27.
You can, and it's one way of showing how it works. Sometimes it's not gonna be that clean though. Sometimes
Okay.
it's not gonna, sometimes it might be log base 3 of 3 times 4. You know, you'll be able to
Yeah.
bring it out that way, you know what I mean? So it might be 12, and you can break it out as, you know, log base 3 of 4 is all that is then. On the other one, did you guys get 5 of log base 2 of 2 squared? So when you do that, did you get 10? The reason why it's 10, these drop by themselves out, you get 5 times 2. Remember, this one falls.
There's no number there, so just go
Yeah. Well, remember, it doesn't die. It falls out of thin air because the log base 2 of 2 is 1. The exponent just drops. And remember, guys, logarithms are nothing more than working with exponents. We're just working with exponents. And then the other one, sometimes when you're dealing with the fractional ones, what do you have to remember when you're working with fractionals? Division, subtraction. But think about when we worked with fractions before, we were simplifying logarithms with the exponents. What were they giving us? Negatives. Sometimes you get negatives. Again, if I look at if I go the long way, if we go the long way of log base 3 of 1/3, it's the same thing as saying log base 3 of 1 minus log base 3 of 3. What's log base 3 of 1? 0. Remember, notice how I'm falling back on these two properties that we were using yesterday for graphing? We keep coming back to these. And then log base 3 of 3 is 1. So your answer is -1. Look at it in other terms. If you look at this, how could you rewrite 1/3 as a, having 3 as a base? 3 to the -1, that's right. It's 3 to the -1. That's why log base 3 of 3 to the -1 would be -1. You're using those properties. Same thing with the last one. If the last one, if you don't want to go the long way, or the property ways, can I automatically rewrite this? Can I do that? Exactly. And again, why did I write it as -3? Because I flipped it. I flipped it, and I wrote it in terms of that one. And I just get -3. Is that okay to do that jump start right away? Absolutely.
That's pretty sick.
Bro. That's professional mathematics.
Ooh, yeah. It's math magical. If you're going to use it, you got to use it. It's math magical. Keep going. Aren't you want to accompany them? You're the singer, I heard.
Yeah. My album never dropped. I had a problem with the record label. It kind of sucked.
Wait, what?
Why don't you get an independent label?
Too much work.
Yeah.
You know.
All right. Well, let's look at it. Let's look at it with variables then. Again, what I want to do here is expand this one out. What I want to do is start to get the idea of how am I going to work with these things with variables and exponents. Again, the reason why we're going to set these things and set this in motion like this is that we will be using these properties to start solving equations. You can see it's not really going to be all that difficult to go through. It looks pretty crazy to me. All right, so what do you see in this problem?
I see the word
Log.
Okay, I see a log, you're right.
plug it in.
We have division, that's what I'm looking for. Does everybody see we have division here? Which means there's subtraction going on. What are we subtracting?
Log.
What is it? At the very end of this, there's going to be a subtraction problem because of the division. It's the last thing on here would be the subtracting of log base 2 of y. Everybody okay on that?
Yeah.
Now, in the numerator, we have multiplication, so there's going to be two things we have to add together.
Really?
We have the log base 2 of 7 plus the log base 2 of x cubed. Is there anything else I can do? Is there another rule here? Yeah. What happens now is that since this has an exponent, it moves in front. So your final answer would be log base 2 of 7 plus 3 log base 2 of x minus log base 2 of y. And that's your answer. That is an expanded form. Now, do you guys kind of see the idea of why I said we're building log forts today? Because we're writing logs, we're using more logs. So we're... You laughing at me? I heard that snicker. And you're trying to pun it up, it was nothing.
I'm laughing with you.
No, you're laughing at me. Uh-huh. I was trying to be witty.
I thought you were ready.
No, now you're just trying to suck up.
Witty, like that.
All right, try
about?
Yeah.
Try those two.
Oh, shoot.
Oops. Try those two.
Faxes and it looks sloppy.
What do you get?
Log 2x minus log 5.
Oh.
Do we agree?
I agree to disagree that we agree.
It depends on what you're trying to do. Again, some of the reasons why we're trying to expand out is because we'll be able to solve stuff a little bit easier. Sometimes you'll be able to simplify things a little bit quicker. And and going from there. This one I'm assuming you guys wrote out is log of x plus 2 log of y.
Yeah.
What you're asking here, Paul, let's say it was this. It was log of base 2 of 4/5, for example. I know that I can write that as the log base 2 of 4 minus the log base 2 of 5. This gives me 2 minus the log base 1. It's going to give us some numerical value at some point. Right now, it's going to help us get it. All right, let's try condensing. Let's go the other way.
If we got like the whole
Search hashtag 34.
Again, in this case here, I'm going to go the other direction. I'm going to condense. I'm going to roll my logs up into 1. This is going the other direction. Instead of expanding out, we're going to condense this. So when we have this written out, does everybody see how it's, I have log of 6 plus 2 log of 2 minus log of 3. What's the base here? Just real quick, 10. Now, when I write it out, I know it's going to have a log. What else do I know is going to happen? There's going to be a division. Good. What goes in the denominator? Good. Numerator. 6 times 2 squared. Because the 2 goes up here then. Everybody see that?
So it'd be log 8.
Log 8, very good. The reason why, does everybody see how that happened? The reason, again, the reason this works out is that you get log of 6 times 2, this comes up here, squared. And when we write it all out, since we have a numerical problem, there's no variables involved, I'm going to simplify it the best I can. And someone already said it, this goes to who? 2 times 2 squared. This gives me the log of 8. And then I'm done.
Alex, you got it. I didn't finish it.
What do you mean? Even like 6 divided by 2 times 2 squared.
Yeah?
6 times 4.
All right. Let's try these.
I guess I just thought.
Try those two. When you get into this one, the one on the left, I'm guessing you guys got right away. 5xy log base 4. Okay. On the other one, it's x to the 1/2 over 4, the log. Now, could you have written it as log of the square root of x over 4? Either one of those is fine. Either one of those is fine. Okay. If you want to leave it as the fractional exponent, I'm fine with that. To be honest with you, I don't remember what the book does. Either one of those is legitimate for me, okay? Not so scary, is it? All right. I'm going to call it quits on this stuff for now. I'm going to give you a handful of these to try out. What we're going to do tomorrow is finish up with the more complex ones. Maybe throw in some natural logs. And then we'll talk about how we work with different bases numerically.
What are we going to do Friday?
Have fun.
We have log forts, log rolls,
And then we're gonna watch.
log cabins.
Really?
Bring in some Tinker Toy.
Yeah.
Can we have?
Can we actually make like
I don't think so. I don't know. I really don't know yet. We'll probably start with equations then. So let's see. This is on same. This is section 8.5.
Obviously.
Page
It's
4.
an electric. What do you expect?
496.
Some people like all these
Oh, man, I forgot what numbers I had. I didn't write it down. Give me a second here, guys. Sorry. I forgot what problems I assigned.
Yes!
Hold on, guys. This takes a second.
Dude, I wanna get tan, I like orange. I do not like it when my skin, I like it when it's nice. My skin is gray.
Getting there. I forgot what numbers I assigned, so I'm just pulling up the old ones.
30 through 36.
14 through 18 evens, 30 through 36 evens, 46 through 48, and 51 all. So it's a couple of the simplifies, it's a couple of expanding, a couple condensing. We'll get into a little bit more complex versions of this stuff tomorrow, as well as change of base formula,
Oh, alright.
which is actually very, very easy. We probably could have gotten through all of it if it wasn't a Wednesday.
When's our test?
Next week, I'm still thinking about doing it on,
Thursday?
yeah. My guess is it'll probably, we're on pace to go for next Thursday, so.